My name is Robert Allen. I'm from Houghton, Mifflin, Harcourt. Some of you may or may not know who we are. Typically, if you do know who we are, you know of us as a publisher. However, our primary focus is learning. Big part of our business is K through 12. We help with instruction, practice, also a lot of research. We work with teachers, students, and district admins to improve the learning experience for students in K through 12. We also provide material and content for the teachers themselves, and this is our primary focus. This is the primary focus from the areas I'm at. I came to Houghton, Mifflin, Harcourt about 5 years ago. I worked in startups. I spent a lot of my intellectual energies in placing ads, robocalling, things like that. And at some point, it really just it was not very a very good experience for me. I felt like I was wasting a lot of energy and not really improving things in society. I had the opportunity to come to Houghton, Mifflin, Harcourt because of a friend of mine that I worked with, brought me in there, and when I got there, I found a 186-year-old company with lots of problems. As a publisher, there's all sorts of diffusion, everything from accounting practices to the way everything is accounted for. It made it very difficult to develop good software. After about a year, it became clear that the problems that we had wasn't really the problem. It was the attitudes about the problems. And really starting to notice that and think about it, I started looking for different ways to solve some of these problems. And at the time, there was a big lift and shift. I'm sure everybody here is familiar with the lift and shift model, right? So you're going to take what you've got in a data center, you're going to move it into AWS, and all your problems are solved. But what quickly became apparent was that cloud providers are like banks. If you don't have a plan for your money, that's okay. They have one for you. And it's going to involve all your money going to the cloud provider. From the development side of the house, engineers would have to wait at least 12 months, and in some cases 16 to 18 months, just for infrastructure to begin development of the product. As you may well know, by that time, your opportunities have gone. They've left you. And when they did get the infrastructure, all of these applications were having to solve these same common problems over and over. Logging, telemetry if they had it, metrics, alerting maybe. And there was this whole process of throwing things over the wall. So if they could get it into QA and QA would pass it, then it would go into a maintenance cycle. And so then it was somebody, in some offshore place that would then have to take their problems and fix them for them. About 3.5, 4 years ago, things were really bad. So we needed to deliver a product. And we weren't able to do it. We already missed it 1 year. And the market was leaving us behind. And a lot of things were in jeopardy. And so what we as a company had to come up with some way that we could get things delivered. And we could deliver it fast. At the time, we literally had 7 months to get this product that failed to deliver a year ago, start it from scratch, and get it delivered. Well, coming into this, we already knew that we had 12, 16 months for just the infrastructure. Painful situation. I had been working literally in basically a closet with one person trying to come up with a solution where we could just focus on what was core to the business. And what's core to our business is providing, learning materials and software to students and teachers, not deploying servers, not metrics, telemetry. All these things are important, but they're not core to our business. They don't, they're really a distraction I say that with caution. It's a distraction from the engineers trying to deliver features and product, but it's equally important. And so we look to focus on that. And we also wanted to change the way developers interacted with what they produced. We wanted those developers to own it from cradle to grave, right? So all the way through to the legacy. And by legacy, I mean it's in maintenance. We also wanted continuous delivery. At this time, releases were only done, the shortest releases were done every 6 weeks. Typically, they would go months, 6 months, 8 months, like once per school year before they would do a release. As you know, this makes it very difficult to iterate your product, right? You can't get, you may have bugs, you may have problems, and if you can't deliver small change sets, you're not going to get those features out. Also, having large change sets like these, every 6 weeks or even 6 months deliveries, you're compounding, your problems, right? So the more lines of code that are being changed, the more features that you're inserting into your product, the more complexity, the more problems, it's a cascade failure. We also wanted to stop trying to prevent failure. So in large enterprises, you tend to create process out of fear. And what happened here is that there was this long process where these releases, not only was the development cycles very long, but there was also a lengthy process of paperwork, literally Word documents that would be filled out, listing all the changes. There would be email lists that would go out where 30 people had to actually approve that the release went out. And so all of these things just really made it difficult to create any product. And so what we wanted to do, we wanted to bring this back. We wanted to put the power back into the engineers' hands so that they could control when the releases are done. And that there was a granular process of reviewing the changes, keep them small, decrease your weaknesses in that release, and really minimize the risk. And then we also wanted to decompose the responsibilities of the services and stop solving the same problem over and over and over. Because as this complexity spirals out of control, you may have one application team that needs a particular feature and another application team needs the same feature, but because the cycle of release was so long, they couldn't wait for other teams to provide these features, and so they would try to solve it themselves. And so you had this repetitious, process of creating the same thing over and over. And so what was formed was what we call Bedrock Technical Services. Now, Bedrock is meant to reflect, the foundations of everything that we're doing today. The saying at the bottom here, this is really a fundamental approach to how we solve these. We don't make Bedrock safe, I always mess this up. We make Bedrock safe for engineers, not engineers safe for Bedrock. And what this means is we don't spend our time trying to make the engineers not break things. We don't spend our time telling engineers they can't do this. We don't want that. We want the engineers to take that opportunity to try something, to break it. Now, what we try to do is we try to isolate that chaos. We've been hearing that a lot here. We try to isolate that chaos from other influences. So we don't want Team A to be able to affect Team B. And for the most part, we've been successful with that. Now, we do this because we run everything in Mesos. We also use containers, but that's a whole nother story. The containers are about the complexity of all the different apps, everybody running different versions of JVM, etc. We use Apache Aurora to schedule the jobs, the batch jobs, etc. And what this does, this gives us the flexibility to have a large pool of resources that teams can operate in and function in some level of isolation. And this has worked really well. There have been exceptions where we find that some things can actually impact others. And what we try to do there is that we step back, we try to figure out what that is and fix it, and make it where it's less likely that other teams can affect others. But all in all, this isn't a technological solution. What it really boiled down to was a people problem, right? So we had these attitudes, we had these beliefs that we needed a process out of fear to prevent things from being broke. And so by decomposing all these responsibilities and the threat that existed of making mistakes, breaking things, we ended up with an environment where now we have this flexibility to launch applications that we may or may not find work successfully. Many do. But ultimately, it's about these core values and bringing that back to the engineers to make those decisions. A lot of this is based on behavioral design. So my team is very small. There's a couple of them here. And so to date, we're a team of 7 people, 4 in Chicago, 3 are in Finland. Now, the ones in Finland work with us as contractors, and they will be leaving the team soon. So it'll be 4 people. We work with about 350 engineers worldwide, and we're running about 1,200 applications in this system now. As you can imagine, 7 people operating 1,200 applications can be quite challenging. We have to do this through automation. And the only way this can work is that we have to make the right things the easy thing. And a lot of times we find that the right thing's not easy, and we have to make the wrong things hard. That doesn't mean that people won't be able to do the wrong thing. In fact, quite the contrary, we find that people do the wrong thing quite frequently. And it's up to us to go back to these teams and these developers or engineers and work with them to find better practices to help them diagnose and debug their problems. As you can imagine, the vast majority of engineers do not have experience working in an environment of problem solving. Let me correct that. In diagnostics of particular problems, they solve problems every day. They're not familiar working in, a systems administration or operator role where they're having to necessarily look at log files in an aggregate fashion, be it at the kernel level or up to the application. And so we work with them and help them solve these problems. We also find that a lot of engineers are very bad at reading documentation. So we try to help them learn to read documentation, read log files, etc. In the end, we set expectations and we communicate those expectations. But what's key to setting expectation is you can only expect what you inspect, right? So if I set an expectation for an engineering team and I don't follow up on that and actually check that they're meeting those expectations, it's moot. It means nothing. And this really goes for everything in your life. If you have an expectation, you must always follow it up with some form of inspection. In the end, it's all about the philosophy. So we empower and we also engage with engineering and ourselves. We work amongst ourselves as a team, but then also with these 350 plus engineers and management. And it crosses not just it crosses divisions in the company. We work with product, we work with, various parts of the organization to help advance the way we approach. There was just a talk in here about security. One of the challenges that we have had in the past is really staying current with a lot of the security. And part of that is because while there's this pressure, you have these competing forces in a large organization. And one of the pressure is to get more features out, and the other pressure is we need to keep things secure. And if the pressure is coming from 2 different opposing, entities, be it, IT security or engineering and security, and then there's, product development, if they're not in alignment, they're working against each other. And so one of the things that, over the last couple of years that we've really worked towards is getting them aligned and working towards the same goal. That requires a lot of education, and it requires, a constant, again, pressure to get those forces aligned. Accountability, that goes back to the inspection, keeping everybody accountable for their actions, what they're doing. But then also, celebrating the successes, but more importantly, celebrating the failures. One of the key things is if you're constantly getting things right, you're never going to truly learn anything because there's nothing there to reflect back on. We try to stay in an environment where things do break. I intentionally encourage that in the team. And for some, it's been quite frustrating. But ultimately, those failures, those misses, are opportunities to learn. But it's important to remember that just because you have a failure, it doesn't mean you're going to learn from it. The learning comes in the reflection. So postmortems, I call them postmortems. Some call them memorializations. For me, that failure is what's dead. So we call it a postmortem. But then we also document that and we communicate it. We see a lot of things that break. A lot of people don't actually notice those failures in our system, but we still communicate them out. We share them with all the engineers, and we share them amongst ourselves. And that's an important aspect of this because that reflection, that investigation is that opportunity to learn. So thank you. If you have any questions, please, I'm open to it.
And if you do have questions, please use the mic.
That went really fast. Sorry. No questions? Great.
Hi, I was just wondering what type of automation or helper systems you guys have to launch jobs on Aurora.
So we rely. So one of the key tools is we use Salt for our orchestration. We also use Terraform. We started out originally using Terraform really for the AWS aspect, and what we're now in the process of evolving to is actually automating, everything in Terraform. And so, like with Apache Aurora, using the Go Realis project, one of the things that is on our project list now, and hopefully we'll be starting soon, is actually moving those jobs or creating an Aurora Terraform provider, and then actually providing, creating all the jobs that are managed in Aurora as Terraform properties. I believe there's a lot of advantages to this. One is being able to recover recover all the systems. In the last 5 years that we've been running Aurora, there was always in the back of my mind this fear that we would lose the job database, and that actually happened 2 weeks ago. So 5 years of fear, drilling over and over. We actually lost our database in Aurora for some strange reason. We still haven't narrowed down why. We were able to recover it. There was about an 8-hour gap. So a lot of the jobs that, changed in that 8 hours, we lost or they reverted. I believe that with something like Terraform, where you can actually have that diff in all your jobs, we would be able to recover that. Outside of that, that's the biggest, that's really the tools that we rely on for that automation.
Okay, so just make sure I understand. When someone wants to increase the resources to their Aurora job, they'd make a change to the Terraform config, and it would roll out and then do a new launch of the job?
Correct.
Okay.
So that's how we would do it with Terraform when we have that. Right now, the engineers are able to set those resources and instance numbers and apply that themselves. We don't restrict that.
So right now the engineers are creating their own Aurora job files?
Yes.
Okay. Thank you.
Yep.
Hey, first of all, thanks for your time. And the question is technology and psychology, right? So teaching a person technical stuff is not a big challenge. It means I lead a team and I'm in IT for 17 years. So changing a person's attitude is always challenging, a person or the team. So we are moving towards DevOps and we are seeing a lot of challenges in that.
I'm sorry, can you speak up? I'm actually hard of hearing.
Oh, okay. So technology and psychology, right? You're explaining both the things. So technology is easy to teach to a team or a person, but changing a person's or team's attitude, it's tough. So what tips you can suggest, like how to approach, like when you're moving the DevOps, we are say out of 10 teams, 2-3 teams are having, they want to do the old way of doing the things. They don't want to change it. So did you got my question, or?
Sorry, could you help me?
He's asking if you have some tips about how to change the culture when some people are struggling on teams and other teams are doing okay.
So to change the culture, it really has to come from two directions, right? So if leadership isn't, behind it, you're going to have a lot of problems. But it also has to come from the ground. What we ended up doing was, so first we got the executive, leadership to sponsor this. But then the next thing we had to do is that individuals in the team, went to Dublin, Montreal, Boston, and they sat with the engineers, literally joined their team for 6 months at a time and worked directly with them day to day. That's an important part of it because you have to set an example, right? And you have to, a lot of it's about peer pressure, whether we like it or not. Even in agile, some teams would, if you're late to a meeting, they put you in a chair in the corner with a hat or something, something like that. But it's really that same thing, right? You have to have somebody has to be on that team influencing it. You cannot influence ideas, people, and practices from afar. It has to be, close and engaged, and you have to actively, identify the things that are right and the things that are not, and provide that, that engagement at that level.
Thank you.
I actually have a question too. You talked about celebrating failure and learning from that and retrospecting on that. How did you celebrate success? Because that's the other side of that coin where you need to reinforce the positive
Sure.
while you're learning from the bad things that went wrong.
So a lot of teams do that differently. For us, it's about pints. So pints and steak. That's a big thing for the team.
You did mention Dublin.
Yeah. So if we're in the States, it's steak. If we're in Dublin, it's pints. Lots of pints. Guinness is my favorite, but we spend a lot of time together, and it's that's a big part of it for us. It helps that we have a diverse team. We have members that are from Europe. We have members that are from the States, and that really helps. That really helps us expand how we engage with each other. I find that in the States, people are once it's 5 or 6 or whatever time they're off, they're gone. They don't want anything to do with any of you. Over there, it's really changed our perspective on how we work with each other because they don't just disappear at 5 o'clock. It's been a big help. But yeah, pints and steak. That's our thing. Every team's going to be different, and a lot of the things that we're doing. This is this important takeaway is a lot of the things that we're doing won't work in every organization. But the idea is that you have to identify that all of these problems are really people problems. They're working with each other. They're improving each other, and ultimately it's about improving everybody's life experiences. I mean, because work is the biggest part of what we do. The team is on call, but we don't. I'm usually pretty picky about what we actually on call for. I don't want this team to have to maintain a system that's constantly falling down, or if it is falling down, I don't want things falling down that we have to worry about immediately. And we really try to keep it very narrow intersection with our personal life. Now, that's not to say that we don't have some things that seem to always be falling down. A particular, database, for instance, that we keep logs in seems to always give us trouble. But, we work through it. We manage it. It doesn't help that we have 4 terabytes of logs in there. And that's just for 30 days. That's how many things that we're running in this. And so as that grows, it's problematic. But we try to keep it to a minimum in the personal space.
All right, please give Robert a big hand. Thanks very much.
Thank you.